I'm sorry for my missing the last two classes. I have the family matters, so I should visit my parents. One of the difficult things is to taking care of parents when I getting old.
Went to Korea?
Very short time.
Wow.
See?
Don't
There's no time to struggle from the jet lag. Okay, so I think the G covered the first part of the file system interface, so I'm going to quickly cover that part and then continue the today's lecture. So this is very important for your project B also, so this one and the next one. So please pay attention to talk about the file system and its implementation. So as we have seen, I think that this part we already discussed before I left. So this is a file, and what is a file? Actually, the file is a data structure for using the operating system, and it's nothing but the sequence of string. However, depending on the application, it's a variety of the data structure. But most of the file has such an attribute, name, identifier. Actually, it is. If you are using the network file system that we are going to discuss later a little bit, so if network file system is very popular in any operating system and the file system, like you can make the remote file system as if you are using the local file system, like the remote drive or the remote file system. But when operating system recognize the file, actually the operating system does not use the file name. It uses the file identifier or file descriptor. Okay, so it's not a big problem whether it has the same file name or different file name, but they recognize the file as the identifier. That is a similar approach as the user ID. So when operating system recognizes whether this file belongs to you or the her, so it's not a problem of the user ID and the group user name and the group name. Instead, they try to use the ID. Okay, so because of that, so when you manage such a file in your file system, it should be managed by such an identifier. What is called the descriptor, and it has more information about the file in the file as a file attribute. So type of the file, location of the file, and so on. This file attribute used a lot. For example, the antivirus program. So, do you know what is the first algorithm to detect whether this file is the changed or not? Antivirus program.
Check the size.
They check the size in your file attribute and the real file size. Check if the file size is changed, then it's maybe there's something problem. But nowadays, even the virus program, they change the file attribute also. So first approach, the first algorithm of the antivirus program. Okay, then we had more information. And the file has several operations. So mostly it's a read and write. And there are some other like the delete. What is a truncate? Anyone who knows about the truncate?
Leave the file?
So leave the data structure. In case of the database, leave the schema. Okay, data structure itself and delete all data itself. Okay, that is a truncate. But if you just delete the file, it deletes all the things, okay? But if you just write the data, it's append, okay? So truncate can be used for, usually truncate is very fast, okay? Because it doesn't care, it doesn't delete the real data, actually it just remove the pointer. That is a truncate. And file has the same problem as the synchronization in the process, which means the file can be accessed by the many processes. So you need to manage the how many the process are using the such a file. That is an open file table. Such an open file table, one is per the file, and another one is the entire system. System-wide, you need to manage the which files are accessed by the which process. Okay? So that is the per process and the per system. So file structure itself, actually the file is the sequence of the bytes. That is a file, but it can be organized differently. So we can use the very simple, the data file structure is the line by line, the new line character. So for Windows system, the new line character is a line feeder. So LF is the new line character. And on the other hand, this is a Windows system, and Unix or the Linux system use the /n. It is the new line character. And also, if you are using the Microsoft Word, it's more complicated, the data structure. So many of the file structure depend on the application. Okay. There are two types of the accessing method. One is a sequential. So sequential access is used for the magnetic tape. On the other hand, the direct access are very popular nowadays. Most of the application can utilize the position or the address of the file that directly find the location. Okay. Then, what if we have the bunch of the files? So to address that problem, then we can have the directory structure, which is the same idea as the folder in Windows system. So directory structure, we have another data structure that can manage the file header information that we have seen. The file attribute, we have the several file attributes, file name, file identifier, and size, date, and the access method. Such an information will be managed in the header file and in the directory. Okay, then that point to the real file. Because of that, even though you delete the file, first when you delete the file in Windows system, it goes to the recycling bin. Okay, then if you flush the recycling bin, then is it really deleted? Actually, just disconnect this one. Okay, disconnect. Or you can remove the header information, file information over here. So which means maybe possible, not always possible, but right after you delete the file accidentally, but there's a higher chance to recover, to restore such a file because of this mechanism between directory and the file. Okay. Then, so these are the file system used in most of the operating system. We have the directory structure in the file system. That directory structure manages the number of files. And the directory structure and files form a partition. So we have the several different partitions. So this partition is a logical concept, logical data structure, which means this can be one disk, and you can make the several partitions. Even nowadays, you can dynamically change it without remove the files and the directory. You can just dynamically increase the partition and reduce the partition size. There are a bunch of different types of the file system. Okay, so NTFS is just one of them used in the Windows system, and in addition to that, much more. For example, even the Solaris 1 operating system, the Unix operating system uses such a bunch of different types of the file system. That is, it's the user 1 operating system has the many different file systems. So that includes even temporary file system, or the UFS is very popular in general for the general purpose of the file system. Even we have the network file system, NFS, that connect to the file system, which is in the remote side. Okay. So what a directory can do in the file system, you can search the file, create a file, delete a file, and so on. Which means if you are implementing the directory structure file system, so first, when you develop the file system, you need to decide the directory structure and file structure. Okay, once define the directory structure, the directory structure should have the several methods. That is the operation method. So it should be able to search the file from the directory and create a file, delete a file. And for example, in current operating system, they provide the system library that can do the search operation. Okay, file is the same. So file has the several operations like to create a file and either search the data in the file. So the operation are implemented in the system library, which means you don't have to directly implement this one. Instead, you can utilize the system library. Then, so directory can be organized differently depending on the purpose. So first, first objective of using the directory structure is anyway, because we have the many files, we need the directory structure, right? So which means they should be very efficient. So how we can locating the file very quickly. And naming is sometimes we can not create if we do not have the directory structure, this is a file system. Okay, and we have a bunch of the different files. All files should be different name, which means different the identifier. Okay, so but for example, he has the GPA file, and she has a GPA file. So we should have a different name. Okay, it's not convenient. So can we address such a problem? That is a naming problem. And grouping also. So he has a GPA file and a transcript file, but these are for the same student. Can you make them group? So if we do not have the directory structure, so we need to have some surface or preface to make them group. So to address the problem of the efficiency naming and grouping, so we can have the directory structure. The first types of the directory structure is a single level directory. As you can imagine, single level directory has just the directory and number of file. So for example, in this case, we have the cat, go, a, test directories. Then each directory has the name of the file. So what about the naming? Naming can be solved. So we can create the same file names, the a.out here, and there is no problem to create the a.out in other directory. So we can solve the problem of the name. Grouping problem, we can make the group like that. This is a student 1, student 2, student 3. So using the single level, so we can reasonably solve the problem of the naming and the grouping problem. What if we have the number of directory? So this is belongs to mine. This is belong to mine. This is belong to mine. This is belong to mine. So it's the same problem. It's a grouping problem. So how can we address? Why don't we make the group of directory for the directory? So that is the two-level directory. So user 1, user 2 has this one. So eventually we can make generalize the directory structure. That is the tree structure. So this is a generalized tree structure. So from top, which is called the root node and the leaf node. So spell in programming, and the spell has this one, and so on. Okay. It's the same as the tree structure is the same as what you are using in your operating system. Similar, but not the same. What is the problem of using the tree structure? You cannot, for example, I give the file, okay, for the project, okay. So each student should have the same file, okay. They cannot share, okay. Also, they cannot group for like this one, okay. Because once it is separated, you cannot combine into two. So that is the problem of the directory structure. So how can we address that one? We can make the graph structure. So graph structure, there's no patterns, there's no the root node, there's no leaf node, okay? So we have just the node and the relationship. So which means so we can one node, one file has the two parents, two directory structure. Okay, that can be doable. What about our operating, like the Windows? How can the Windows implement such the acyclic graph? Using shortcut. You can create the shortcut. What about the Linux or Unix? How can they implement such the share of the file for multi-directories? That is called, we have similar link. Using the link, you can create such a cyclic graph. There are two types of link in the Unix system. One is a soft link, another one is a hard link. Soft link is just a link, like the shortcut in Windows. This one belongs to here, actually created under the count. But from this count, you can have just a pointer. Okay, that is a soft link. Hard link means when you create a hard link, under the count, another directory, it will be copied, but they should be synchronized. So which means if somebody changes this one like the black, this will be black at the same time. It's the same. Physically, two copies, clone. Okay, they are synchronized. That is a hard copy. So using ln command, it's a link command. You can create such a. You can implement the acyclic graph. So acyclic graph means it's a one direction. Okay, to implement the characteristic of the tree structure. And I skipped this part. I think that this one is obvious. So there are two types of the path, absolute and relative path. Also, during the exercise lab, I implement some special the directory. So dot is the current directory, and the double dot is the parent the directory. So we have a link. So this is a general graph directory structure, which is the same as what we are using in our current operating system. Okay, so it has the last week when I tested the Java program. So actually I have two projects. Project 1, Project 2, using the NetBeans. So I tried to include the jar file to the Project 2, but accidentally I included myself. What happened? So forever, keep creating, so then finally something error, weird error message to delete. Once I realized, so I tried to delete the project file, but Windows cannot delete that file because it's a too long path. So when I get inside, it's more than 1,000 the subfolder. So there's no way to delete the directory. So because of that, I installed the Cygwin. This is one of the, I forgot to mention about this one. This is the Windows application to mimic the Unix environment. Those who want to can use the Unix or the Linux environment, you can actually install the Cygwin. The Cygwin is the Windows application, but the Linux style interface. So this is good for the those who are not familiar with the Linux system. So this is just the interface. So for example, you can type the pwd. Pwd is under the home. So me, and for example, you can see you can actually see the C drive. Okay, so you can do the same thing, like so different from the virtual machine. Virtual machine is a separate the operating system, but this one Cygwin is nothing but the interface. Okay, so you can do the same thing as you are using the Linux system, but actually it's for the Windows system. Using this one, I can successfully delete the file. It's a very long path file. So that is actually the problem of the general graph directory structure. Okay. So like this one, there might be loop, the book reference the ABI reference the book. Okay, with the parents. What if we delete the ABI? Then what about the book? It's a subdirectory of ABI. Actually, the book is the parent of the ABI. Okay, so that can be the problem in general graph directory structure. So that needs the garbage collector. Okay, from time to time. So there is a garbage collector. If in case there is a subdirectory which is supposed to be deleted but not deleted. So, once you purchase the hard disk drive, your hard disk drive, so you need to install the file. The first time, this is a low device, but nowadays when you purchase the hard disk drive or the SSD, they actually install the default file system like the NTFS or the FAT32. So it has a file system, which means there is a directory structure. There are a number of files already inside your disk. Like even the memory stick is the same concept. So this one has a file. Okay, it's a file system. It has its own file system. What if I try to use this one on the existing file system? Okay, this is the home and JELEE. This is a memory stick. Okay, my memory stick. So I'd like to use this one to connect this on the memory stick. That is called mount. So we already see the current operating system bunch of file system. They're using the one operating system. How they can be connected using such a mount command. You can connect the existing file system to your operating system file system. So at the time, this is called the mounting point. So you can connect the existing file system to the mounting point. Okay? So there is a mounting point. So for example, here, so let's see that this is a root user beer and Fred. If you mount this one to here, it will be replaced by the where is it? Jane and Sue. So this one, if you mount the this existing file system to the user, then this one will be hidden. Then you can see the connected, mounted, the file system. Okay, like this one. So this is an example of the. I don't think we computer science department still manage the CP server. So a long time ago we had the CP server. So that has such a mounted different file system. For example, this one is the network mounted network file system. So that they are mounted to from remote system to the local. This is the file system mounted to the, for example, root. It's a DV disk C0, T0, D0, S0. It's a controller 0 and T, I don't know, the D is a disk 0 and cylinder 0, something like that. That is mounted to the root and so on. So you can use the mount command. I'm not sure the Cguin has the mount command. Yes. Yes. Even this one shows the mount shows the Cguin/bin, so USB. Antivirus is mounted to the C and the Cguin 64. Then this is a same example, same server, but you can see the size of the file system, how many of them are used, how many of them are available for each file mounted file system. Okay. Then when we have the multiple file system, we should be able to share such a file. So at the time, the file sharing will be based on the user ID and group ID. Okay? So we can give the permission to the user ID and the group ID. Okay? So if you list up using the ls command or dir command, so you can see who is the owner, who is the group, and at the time you can see the owner ID and the group ID. Sometimes you can see 400. Instead of the name, you can see the number. That means this is the group ID identifier. Actually, the UV stem or the JELE should have the ID and the group ID, but for your better understanding, it shows the name of the user, name of the group. So, but actually, they are managed by the ID, user ID and group ID. The next one is a protection. Protection means it's a permission in the file system. So we already seen during the exercise lab. So for example, read in Unix system, read, write, execution. There are three types of the permission: read, write, and execution. And also same thing for this one. This is the owner. And this is for group, and this is for public. So then this one is a 421, 421, 421. In case if you, for example, if you want to give the full permission to the owner and the group to this one, and the public is for it will be 754. The permission like this. Okay. This is the same example as this one. So owner and the group and public. So for example, 761 means 7 is a full permission for 421, and the 6 means the 42, which means read and write for group, and 1 means 1 is the execution, only execution for the public. Okay. I think I gave the homework to you guys before. There's one more bit. This is a 9-bit, and there's another bit at the top. So in case of directory, it's a D, and there's more than the T, S, and small s, largest. Anyone who remember? I think I gave the homework for this. Anyone?
You didn't give the homework, you covered it earlier in class.
But you don't have to submit. I think I didn't ask you to submit it, but just for your research. Anyone who researched what is the S and what is the T? So when you when you are using the Linux or the Unix system, you will see such a permission like the 754 read write execution RWX something. But you can see the one more. Let's see the. So you can see there are 9 bits for the read write X, read write the execution RWX, and one more bit. So D means obviously it's a directory, it's a folder. Then there is a other T and S and largest. The T means it's a temporary. So like the /tmp. /tmp is a temporary space. Even though you do not delete the file, when you restart your system, some of the temporary file will be automatically removed. This is a temporary. S is the sticky bit. Sticky bit is very interesting. The file permission. So you can give the file permission to, for example, I have the when you connect the database server, such as Oracle, so how can you connect the Oracle database server? You need to set up network configuration. So using username and ID under host name, IP, that is the IP address, and port number, then database name, you can connect. When you connect the database server from the client, and process will be, after you successfully connect, there should be process that can receive the request, that is Oracle. Then your process, when you successfully connect, there is a new process that is Oracle. This one is a fork from another Oracle's process. Okay? So at that time, even this Oracle has the full permission to access the data file. But you don't want to give the full permission to the user. Instead, if you have the execution permission with such as S, sticky bit, then once you execute the file, then you have this one is a fork and you have your own file. This one, you can take over the permission. That is the sticky bit. Even though you do not have the directly the permission to the file system or whatever, but when you execute the file, and the process has the permission. However, sometimes because of such a characteristic, it can be used to hack the system. You can actually inject something other code. So because you will eventually get the permission. Even though that is only limited by the process, if you can inject some your code, then you should be able to access some the important file or the process. That is a sticky bit, and they are a little bit different. The largest, I cannot remember the largest, which is not very popular, but for your understanding, you can research on S. There's other, much more than that actually. There's a capital letter T and the capital letter S, but these are called the sticky bit. What about the Windows? Windows also has quite similar, the access control. It has the full control, but full control includes the modify and read and execute and read, write. and special permissions. So actually they are based on the read-write, the execution for each user and group, okay? And also public, like everyone, the administrator, and this is the guest. The guest is the public, and the something group, system group, or the something group. So they are basically just almost the same access control. Okay. Before we start the chapter 12, file system implementation, I'd like to check the midterm exam. Okay. I'm going to call your name.